Hello, it's your teacher, Mr. Riffee. I'm here to provide you with Riffee's notes and insight on how not to jack up a gel electrophoresis. Sarcasm provided by Riffee. Without further wait, here we go. So you're going to be doing a gel electrophoresis in Principles of Biomedical Science. You might as well familiarize yourself with some of the equipment. Let's start with the power supply. The power supply looks exactly like this, and it even has the word power written on it. If you need another angle to view the power supply, try the forward view. These power supplies are provided by Biorad, and they've kind of made them dummy proof. If we're looking at the back side of the power supply, you will notice there is a fan and a place for you to plug in the power cord. The power cord looks like this. This end of the power cord gets plugged into this part of the power supply. And from there, you run the opposite end of the power cord into an electrical outlet. But only one electrical outlet, largely because there's only one plug. From there, once you have the power supply set up with the power cord, you're going to want to press the power button and turn it on. That would be located right here. It is a switch on the back right hand side of the power supply. Once you've switched on that power supply, you will notice it turns on. Once it is turned on, you should see a value of 0 on the screen. Other things you should see is you should see that the voltage, or V, is lit up right here. And you should also see that the V for voltage is lit up down here. If they aren't both lit up, please come see your teacher. Other things you will need to know about the power supply is you can adjust either the voltage, milliamps, or the time frame in which you want to run the gel. The only thing that you're going to actually be adjusting is the voltage. So making sure again that the V is lit here and here, you're going to want to raise the voltage using the up arrows, considering we are raising it up. And you're going to press that button until you reach the desired value as specified by your teacher. That was the power supply. Now we'll move on to the other pieces of equipment, largely known as the electrophoresis chamber and the other stuff that goes along with it. So let's familiarize ourselves with some of the stuff. This apparatus as a whole is the electrophoresis chamber. You will notice it has several parts to it. The first, it has a lid. That lid is securely placed on top by the electrodes. You have a negative electrode indicated with a black color and a positive electrode indicated with a red color. They've dummy-proofed how you put this lid onto the chamber itself by actually color-coding the footing. If you will notice, if you look closely, the footing for this part is black and the footing for this half is red. If they don't match, it will not go together and it will not work. You will also notice there are cables running from each electrode. One is black and one is red. Again, color coding it for dummy proof. Once you remove that lid, you will notice that there is an empty chamber inside of here. Inside of this chamber, we are going to fill that with TAC buffer solution. About 400 mils of buffer solution are going to go into this entire thing. The main goal is to fill it until it totally covers what we call the gel electrophoresis tray. This, my friends, right here is the gel electrophoresis tray. This gel electrophoresis tray holds, believe it or not, the gel. The gels are created by your teacher. However, if you would like to know how those gels are made, feel free to ask your instructor and he will show you how simple and dummy-proof it has become. When you obtain your gel, you're going to lay it flat, well side up on your tray. The wells are these holes cut into the gel itself. Once you have your gel placed on top of your tray, very carefully, I might add, because the gel is extremely delicate, about as delicate as Jell-O itself. Because, let's just be honest, it pretty much is Jell-O. From there, you're going to take that tray and you are going to place it back in the chamber with the gel on top of it. So basically, what you need to know is that this bad boy right here gets put right back into this chamber. They've also dummy-proofed this process. There are two places in which you can place your tray. These chambers are designed to have not one, but two gels run in them at the same time. However, you're so special. Your teacher has designed this so you, by yourself, as a group, can run just your own gel in your own chamber. Therefore, let's put that tray inside this notch here. If you have it the opposite direction, it will not fit. So this notch ensures that you have the tray in the exact spot in which it is required. You will also notice by careful inspection that the electrodes themselves have an indicator on them indicating the charge. Red is positive and the black is going to be negative. This is important as earlier this year you learned that DNA itself is a negatively charged molecule. And a negatively charged molecule in the presence of another negatively charged substance will repel each other. On top of that, the negatively charged substance is attracted to the positively charged end of the electrode. What that then causes is DNA to move from the wells down the gel towards the positive end of the chamber. Another thing I want to point out is the fact that if you look on top of the tray, they have yet another dummy-proof indicator to setting it up correctly. On the tray inside the chamber, you will notice there is a negative symbol, indicating that it needs to be on the negative end of the chamber. If you notice on the lid, there's the negative symbol, otherwise known as the black electrode. If these two things match up, thumbs up. And the last bit of information you need to know is you can't run a gel electrophoresis without the chamber being hooked up to electricity. That electricity is going to be provided through the power supply. It will be supplying the power. How do you hook this up, you say? Well, believe it or not, we can run count them, four gel electrophoresis chambers on one power supply. The most we will be running on individual power supplies today will be 2 chambers. One lucky group might just get to run their own on their own power supply. How do you hook this up again, you say? Well, the black wire goes into the black hole. Make sure you push this in all the way as to secure a connection with the power supply. The same thing is to be said about the red wire. It goes in the red hole. I know, it's something of genius. What do you do after that, you say? You're going to have to wait and get instructions from your instructor. Let's talk about the micropipette and its friends that go along with it. The micropipette is going to come in a box that is labeled AccuMax. AccuMax is the company that makes our micropipette. Our micropipette happens to be a micropipette that measures from 20 to 200 microliters, as indicated on the label right here. 20 to 200 microliters is not that much fluid. Let's familiarize ourselves with the actual micropipette. What you have here at the top is you have a dial. This dial right here changes the amount of liquid that can be drawn into the micropipette. This dial is an indicator of the microliters. By twisting this dial, you can change this value, thus changing the amount of liquid that can be drawn up into a micropipette. Other items of interest. You have a hand rest. You also have a micropipette tip ejector. When depressed, this button right here will cause the white portion of this micropipette to extend forward, pushing the tip off of the micropipette. Something you also need to know is our micropipettes have a double function to them. Not only does this plunger up top right here actually change the amount of substance when it is twisted, when you depress it, it will draw up a substance. These are a two-step micropipette, meaning when you push it down, you will feel that it will come to a stop at one step. When you push that down to that first step, it will draw up this amount of substance. After you're done drawing that up, you release the plunger in the upward direction. You will notice that in the bottom here, you will find there will be the exact amount that you want to draw up. The second step on this plunger happens to be used to expel all of a substance. So by pressing this plunger down to the first, then second step, you will expel all of the solution plus some more that is in there. Other things you're going to need to know. These are micropipette tips. Micropipette tips get put on the end of the micropipette. How do you do this, you say? You hold the micropipette in your hand and you insert the micropipette into the tip, pushing hard into the tray, and the tip will then be on the bottom of the micropipette. Notice in this example the precision handling and expertise demonstrated with a micropipette. Fingers underneath the hand guard or hand rest, thumb on top of the plunger. He can read the screen if necessary. And one very, very, very big and important thing is this micropipette is kept in the upright position with the tip pointing down. At no time, absolutely no time, do you want to tip a micropipette upside down. This is not good. Do not do this. Fluid, substance, liquid, whatever you're drawing up will travel down into the micropipette, ruin the calibration, and these things, let's just say, are not cheap. Once you have your micropipette tip on the end of your micropipette and you've drawn your fluid up to alleviate contamination of substances, you will only use one tip for each DNA sample. Otherwise, if you use the same tip for multiple DNA samples, you will end up with contamination of DNA and your results will end up jacked up. How we avoid that? We have this thing called a beaker. That beaker is going to be used to eject micropipette tips into it. Only used ones. How do you eject it, you say? That is this white ejection button or plunger right here. By pressing this down, it causes this tip on the end to fall off into the beaker. This is how we properly dispose of them. I hope you found this introductory video as informative and sarcastic as you could possibly take. Please let me know if you have any questions. Best of luck on your gel electrophoresis.